Well, we've got it in the R40 collet chuck, and we're going to take our first cuts, see what it machines like. Feels okay to me. A bit more on it. It's machining okay, yeah. Well, I'll keep going at this and I'll come back when it's done. Well, that has machined up very nicely indeed. Got quite a nice finish on there for the face off. So now we're going to move on to the outside edge. Obviously that's going to be a bit of an interrupted cut to start with because, well, you've seen the edge, it's a little bit on the rough side, but we're also probably going to slow the lathe down a bit because you're looking at really, ideally for this diameter, I don't know, 300-400 RPM. So we can run it a little bit faster because we are, you know, using a carbide tip. So let's bring it down a bit. There we go. Yeah, that's cutting okay. Well, that's pretty much done. Cleaned up really nicely. So what we've got to do now is swap the ER40 collet chuck out for probably the 4-jaw, and then we can hold that way and machine the other side. And then once that's done, flip it back around, put it back into the collet chuck and finish this off. Okay, so actually using the 3-jaw. And we've got it chucked up. I'm not using any soft jaws because I'm going to be turning more off of the outside edge of this pulley anyway once it goes back into the ER30 collet chuck. So just the centre in there, hold it steady. Machining quite well though. I'm quite pleased. The aluminium is machining very well. Yeah, anyway, you get the idea. We've seen people face off parts on lathes loads of times, so I'll bring you back when we're done. Right, faced off nicely. Now we're going to center it so that we can give it some tailstock support while we're machining this face here. Wind the revs up a bit for this. There we go. Job done. Right, let's get on with turning the sides. way too fast, I think. It's more like it. Skim it first to see how it's turning and then we'll take a deeper cut. That's okay. Well, that finish isn't very good, so we'll have to fiddle around with the angles, but yeah, we've nearly taken off most of the casting marks, which is what the whole point of it was. Well, this turned down really nicely, so we're just doing this face now. I've got to make some more passes on here, but I'll do this face first. Yeah, nice. That's very nice. Yeah, I think that'll do. Then we'll go back to this. Right, well, we'll give this a little bit of lube. There we go. Wind on a bit of cut. Yeah, it's machining very nicely. Quite pleased about that. Bring that in. There we go. Pull that out. Lovely job. So I've reduced the thickness of the pulley blank here down to 10mm, which is what I want. And now the next operation is to create the V. The V on the original pulleys, on the original motor, has a slot. Flat slot base, so the V sides but flat slot base. So we're going to go in 184 thou using the parting off tool to create the slot initially. So here we go. Well, I'm going to keep going with this. It's going to take some time, but you get the idea. So we've now got a slot in the center of our pulley blank. It's 184 thou deep, which is what it was on the original pulley. Now we've got to create the V. Now, unfortunately, I don't have a tool which is the correct angle for the V belt profile. However, I have found that using the standard carbide tip, indexable carbide tip tools, it's not far off the right angle, and it works fine on the pulleys that I've made in the past. These kind of belts which I use, they're very squishy. They actually will conform to the slot you put them in. So yeah, that will do the trick. So we'll put the right tool in and we'll have a go at making the V. Well, you get the idea. I'll come back when it's when we're nearly there. Okay, so that's the groove done. You have to take it steady because obviously you're doing a plunge cut. If you want to know how deep I go, well, that's kind of a guesstimation. I basically test fit the belt until it's roughly goes in so that it's flush with the outside edge, and I found that to be absolutely fine for gripping. So that's that done. So next stage then, we've got to center drill and drill and ream this 10mm. So that's the next operation. Center drill in. Nice and easy. I think we'll go in with the 1/4 inch drill first, and then we'll go up to 9.8, whatever I've got that's closest to 10, which is the pre-reaming drill. Okay, 1/4 inch drill. Bigger drills are easier because they fruits clear. There we go. All the way through, I think. Pull that out. First hole done. Well, it looks like the closest I've got to 10. Reaming size rather for 10 is 9.5, which is fine, that's okay, so we'll use that. Let's slow this down a bit. Let's try that. So we didn't quite go all the way through with the, with the 1/4" drill, but never mind, no problem. We're there now, and that's ready for reaming. Hey. Okay, 10mm reamer in. Gonna have to slow it down a bit, it's going a bit fast. There we go, that's more like it. I think we're nearly there. Yeah, definitely all the way through. Right. Pull this out, and I think that will be it for today. I've still got to cross drill the boss and cut the boss down to length, but we're nearly done. But it's pretty much beer o'clock time, so I think this will do for today. Right, the next operation is to drill the pulley boss and tap it. I'm going to use 4BA grub screws to hold it onto the shaft. So it's kind of hard getting a decent angle on this because obviously what I've done is I've pulled the pulley out of the chuck a little bit. Now we're not going to be rotating it, but it is holding it reasonably firmly, certainly firmly enough for the cross drilling. So I've got my cross drilling attachment in on the tool post, being driven from an old Black & Decker electric drill via a flexible drive, and we're just going to center drill it to start with. So here we go. Right, that's that done. Now I'll swap that out for the tapping drill. Tapping drill in place. Right, well that was relatively painless. Now onto the tapping. Now I'm going to start the tap off. I put it in the little chuck here, and I'm going to start the tap off manually by doing it. That just means that I get it lined up nice and straight. I'll do a few turns, get it to bite, and then I'll remove this and we'll just put a normal tap wrench on. So it's a bit awkward because obviously this isn't really designed for this, but you can get it started this way. Which really gets the tap lined up nice and straight. There we go, that'll do. Let's just bring that round a bit more. There. Now I can loosen this off. and then bring the cross slide back out. Clears the tap. We move the carriage out of the way, rotate that to the upright position, and I'll put a little tap wrench on that and we'll finish it off. Okay, last operation. Just face off and clean up the boss for the pulley using Poor Man soft jaws here. This is a bit of an old belt sanding belt, which does make quite good soft jaws. Now, I didn't part this off. I actually used the Hexacut power hacksaw to chop that off. Reasons being, it's always worth considering ways of doing these things. Now, yes, I could have parted it off, but it would have been very messy because I've had to use a lot of coolant and it would have made the lathe covered in that. And the Hexacut will go through this kind of aluminium like butter. So stuck it in the Hexacut. I had plenty of material out this way to hold on to, and it literally took a few minutes for the Hexacut to cut through that. So yeah, way better than actually using the lathe to part it off in this instance. So what we'll do is we'll spin this up, and we'll just clean up this end. Might take a fair bit off actually, because I don't need all of that boss on there. Yeah, I'll take that down to, I'll probably take another couple of mil off of there, and then we'll break that edge, and we should be done. Well, there it is, finished. The pulley in all its glory. Turned out all right, I think. What you remember, of course, is that 2 days ago this was just some lumps of scrap aluminium. So the beauty of being able to do this is that you can make things like this pulley to your own size requirements. You're not stuck with whatever is commercially available. You just make your mould the size you want it, provided you've got the flask and you've got the ability to actually melt enough aluminium. You can make it anything to any size, and that is just so useful. It didn't really take a lot of effort. This has taken about a couple of days probably in total with the casting and the machining. So yeah, I think the ability to cast your own stuff is really useful. Okay, let's get it on the mill and see whether it does the job. Well, the new pulley's fitted, which you can just about see in there. Unfortunately, I don't have drive belt the right size for it, so this one is just too loose at the moment. It'll work to drive it, but it's just going to slip, so I've got to get one that's the right size. But yeah, it works. If you watch the speed on the counter there. That's about midway, I think. Wind it right up. Over 3,000, which is what I wanted to achieve, but it will actually go flat out 4,170. That noise is the belt flapping around. But I've achieved my aim. That's the important point. So there we go. New pulley for the mill, all operational. So I hope you've enjoyed these 2 videos that I've done on making this pulley for the mill motor. Very satisfying to make your own stuff, particularly when it involves casting and the rest of it. So as always, thanks for watching. Cheers.